So I'm going to pose this question, and I'll talk a little bit about the phenomenon of coral bleaching, which Carl so eloquently introduced. So let me start out with what bleaching looks like underwater. So this video dates from March the year before last, so 2016. It's a reef near Cairns. It's about 70% bleached, and about 30% of those corals died in the 6-month period afterwards. So a marine biologist like me studies reefs underwater using standard gear like fin's mast snorkel, an aqualung, and a boat is often handy. Boats occasionally sink, but they never fall from the sky, where small helicopters occasionally do. So to answer a very basic research question, where is bleaching in 2016 and tragically again in 2017 occurring along the length and breadth of the Great Barrier Reef, and where is it severe, where is it mild, and can we explain those geographic patterns, the footprint of the bleaching in those 2 consecutive years? We took to the air. So I'd never been in a helicopter in my life, and I'm sure 15 minutes worth is a joyride, but I can assure you 30 hours in a helicopter where 2 of the doors are left behind in a cane paddock is actually pretty grueling. You have to keep putting sunscreen on because in the tropics you'll get burnt to a crisp through the perspex screen, and the noise is something else. But we flew over the length and breadth of the Great Barrier Reef in a chopper and in a small plane. It takes about a week, 7 or 8 days, to cover the length and breadth of the Great Barrier Reef. So these red squiggles are not the flight paths of a very drunk pilot. There are sampling designed to fly over the top of a little over 1,000 reefs out of the 3,000 individual reefs that make up the Great Barrier Reef. So the idea is to fly low and as slowly as you can without stalling and falling out of the sky, and scoring the reefs for the intensity of bleaching to generate a map, which I'll show you in a moment. So what does a bleached reef look like from the air? So it looks like this. So the bleaching in 2016 was by far the most extreme that we've ever experienced, not just in the Great Barrier Reef, but around the world. 2015-16 was an El Nino period, and we saw a global bleaching event that affected many reefs in many countries. We'd seen bleaching twice before in the Great Barrier Reef. The first time ever was in 1998, also an El Nino year, but then it occurred again in 2002, which was not an El Nino year. Again, last year, also an El Nino year. And finally, the 4th event in 20 years was this year, 2017, outside of El Nino conditions. So you don't have to have an El Nino in order to get severe bleaching. So based on our aerial surveys, we've produced these maps. So red is bad, and green is good. So on those red reefs, more than 60% of the corals were bleached. And as Carl said, we confirmed the accuracy of those numbers by surveying about 150 reefs underwater. The green is good. That means little or no bleaching. So the northern third of the Great Barrier Reef bleached last year. And as a consequence of that, 1 in 3 corals along the entire length of the Great Barrier Reef died in 6 months in 2016. That includes the bottom third where there was no bleaching. So the mortality rate, the loss of corals where the red reefs are, was about 67% in the northern 700-kilometre stretch of the Great Barrier Reef. It was an incredible dieback of corals. We'd never seen anything like it. And tragically, that event has happened again, but this time in 2017. The footprint is different. The most severe bleaching has occurred in the central section. So between both bleaching events, we've now seen severe loss of corals, in total close to 50% of the corals on the Great Barrier Reef in less than 18 months. The difference in the footprint is explained by where the hot water was in each of those 2 different years. So it was hot in the north in 2016 and hot in the central this region this year. So to answer our question, will coral reefs survive climate change? Well, so far we've seen, with 1 degree of global average warming, 4 major bleaching events on the Great Barrier Reef. The last 2 were much more extreme than the 2 earlier ones in 98 and 2002. So if we achieve the COP21 Paris Agreement targets of 1.5 to 2 degrees, that's a global average for both the tropics and the poles, for both the land and the sea. So the tropical ocean, if we achieve a COP21 2-degree global average target, that translates into another amount of warming in the tropics of about 0.55 degrees centigrade on average. It's very patchy within the tropics. Some areas will warm about double that rate, and other areas will warm about half that rate. I actually think that's doable. It won't be comfortable for coral reefs, but certainly business as usual emissions, which would take us to 1,000 parts per million of CO2 in the atmosphere compared to 450 to 500 under the COP21 agreement. That will cook coral reefs because we'll be looking at global average increases of about 6 degrees centigrade, which will certainly be far too hot for the world's coral reefs. So the answer to this question doesn't lie with scientists, it lies with you. It lies with society. It's up to us to sign up to the COP21 agreement to achieve the target of 1.5 to 2 degrees of global warming. And if we can do that through public opinion, through influencing policymakers, by voting for the right political parties, then I think there will be a future for coral reefs. Thank you.